Rahim. This is October 1741 variant question number 5. Sorry. Have a look here. Particles start from O. It is a very clear. Wait a minute. Just a minute. Yeah. In this question, it is a very clear mention here. When the particles start from start, okay, not rest. It means time is 0 and s is 0. That's it. Okay. The velocity of the particle is given by in a two format 0 to 5 seconds. We have different pattern of motion, and after 5 we have a different pattern of motion. He said that find acceleration when after during first 5 seconds. It means I will utilize this equation. So he mentioned clearly that use till 5 seconds. So over. And student, whenever you have a displacement, one step up, velocity, one step up, acceleration. If you differentiate, you go up. If you integrate, you get this kind of answer. So we are on the level of velocity. I need acceleration. So I will differentiate. So let's start. When differentiate, student, what happens? I got acceleration. This derivative becomes 0 and t become 1, so 1.4. So Alhamdulillah Rabbil Alameen, 1.4 meter per second square is my answer. He was asking find acceleration in the first 5 seconds. Done. When the find the velocity, sorry, time when the particle is at rest. Common sense, upper
Huh?
equation we can't use. Upper equation we can't use. Oh, sorry, 0.4. 0.4. Sorry for that. It's not 1.4, 0.4. Okay. All right. Let's talk about the next part. Can I use the first equation for the rest part? No. Reason, even I plug in time 0 here, you got velocity 1.5. We can't use above equation because particle is not stopping in the first 5 seconds. So it may stop in the next 5 seconds. So I will use the second equation. V equals to 100 over, I bring it up, and 0.1 t. So this equation, this expression I used. So first of all, I will, because he said that, okay, why I brought it up, I will not differentiate. So I'll leave it down. So 100 by t to power 2 minus 0.1 t I took as it is. And I'm going to plug in, put velocity 0. Very clear logic, rest. So I'm putting 0, and now let's try to find it. And algebra, only algebra, this whole thing come left side, 0.1 t equals to 100 by t square. Cross multiply 0.1 t cube equal to 100. And this 0.1 goes down, I got 100 by 0.1. And this become 10 above, so 1000. So 20 take 1000 t cube root, I got 10 seconds. So Alhamdulillah Rabbil Alameen. It means clear that this particle stops when it is a time is 10 seconds. Okay. So now let's talk about last part. 5-mark question. Total distance traveled by the when first 10 seconds. Now, student, here I will do some precautionary measures. What is that? I'm not confident that what particle is going below x-axis or not, because logically you know that whenever distance is particle goes up and down, here this positive distance and there's a negative. Okay, and this is it is distance he's going away from observer, and this distance is coming back to observer. Okay, if this observer is standing here. So velocity positive, velocity negative. So I'm not confident about this one, so I will check it. How I check it? Because I will check that is this particle velocity is coming negative or not. So let's see the important part. How to check it? So there is one technique. You can plug in after 5, because 100% we confident at stopping at 10. So from 5 to 10, I will check. How I check? I will test with the 5, 6, 7, 8, 9, or 10, or I have a function mode table function in our calculators. Okay, I will use this function. If the velocity is coming negative, then I must sketch the graph, because if I must sketch the graph, so some part above and some part below. But what I feel and I observe in this question, the particle velocity remains positive. It means it is not coming down. And I show some rough diagram to you even. So look, student, look the way. So till 5, we have different pattern. Till 10, different pattern. Student, I'll show you both. So this is okay, before I start, I will tell you 4 things. If t value is positive, we have this kind of graph, this kind of graph. If t value negative, we have this kind of graph. If t square positive comes like positive. So we have this pattern graph. If negative comes, we have this kind of graph. If t cube positive, we have this kind of pattern. And t negative sign here, we get this kind of pattern. And keep your eye of 2 things. So have a look, please. What is this time positive? Look, I'm writing 1.5. Velocity equals to 1.5. plus 0.4t. So my question, is this t positive or negative? Positive. So we have this kind of graph. Okay, it is, what is this called? Y-intercept. Okay, so it means the graph is going and against 5, if I want to check it, so plug in 5, this 5 is here. Okay, I'm typing in my calc, although this is not compulsory what I'm doing, but I just show you. My answer is coming 3.5. So it means 3.5, it means at, so starting 3 and 3.5. So this is a 3.5 and there's a 1.5. Okay, now there's a one pattern of motion. When you talk about this pattern of motion, students, so it is a coming a pattern of negative. The graph is coming like this and coming and coming and stopping here. You can ask me how you know, sir, because when you type in calculator anyway, so you can type in calculator and get the pattern of motion anyway. So you know it very well, student. This area we get by integrating the first equation, and this area we get by integrating second equation. So let's try to solve it. One is 0 to 5 and second is 5 to 10. So let's start. So 0 to 5 plus 5 to 10. I can find the first area by trapezium area as well. Half into, trapezium area. If you want to avoid integration, you can find by trapezium area even. So this is okay, trapezium area. How? Look, I'll show you. This is 1.5, this is 3.5, and this is a 5. How come? There's a 5 coming here, and this at 5 velocity is 3.5 is 5. So this is another way, but I'll show you both answers. Get ready. So this equation I took from here, and I cut from here, and I get it here inside here, right? This one. Okay, so this will give us the first answer. Okay, and it will match with this answer. Second equation, I have what? I have second equation is here. This equation I will copy from here and paste here. So I believe understanding what is going on. So this second equation. Now I'm going to integrate. So when I integrate this 1.5, all of you know 1.5t, and when I integrate this one, increase the power by 1, divide by same, and 0 to 5 is done. So what about this, students? Can I integrate directly? No, I'm bound to bring t square up. So let me type 100 t to power negative 2. Increase the power by 1, divide by same, and here's 2 by 2 and 5 by 10. Now I will just type in calculator and get the answer. So wait a minute, although I can show the working even, and wait a minute, I'm going to type, and wait a minute, this is a 0 to 5, and I'm getting this answer 25 by 2. It means this first answer I'm getting 25 by 2, and now I check the other one, and the other one, if I type in calculator, 100 divided by x square minus 0.1 times 2x, and the lower limit is 5, upper limit is 10. This is coming me is 25 by 4, and wait a minute please, 25 by 4 plus 25 divided by 2. So this, and answer is coming 18.75. And hold on, I want to prove it. This is answer same. Check please. What is the trapezium area formula? Half into h into a plus b. H is what? 5. A is 1.5. B is 3.5. This is a 5. 5 is 25. 25 by 2. So alhamdulillah rabbil alameen, which is matching. You see, it is matching. So you can avoid integration. If you have a straight line, make sure, students, you have two options. Either triangle will come or trapezium will come. So you can avoid integration, but if you feel confident with the integration technique, so I think this is easy. Otherwise, some you have forget the formula of trapezium, or you are not confident about it. So I think the idea is very clear, and don't forget this kind of graphing. Okay, so I hope so the concept is very, very clear.